So previously we created an FK network, and this will be the basis for any rigging setup which we create. We now need to look at how we can extend a network like this. I'm not going to extend any functionality yet. Instead, I'm going to focus on how we actually perform the extension and how we'd update an existing network. We'll be looking at this in the context of the auto-rigging network, as well as how we'd do this using the base Apex node setup. And we'll look at what's basically needed to add components to a network. I may have some issues with some parts of the network here. These issues are not actually part of my setup and are basically bugs in this version of Houdini. This is something that you do expect from beta software. These bugs do not actually affect the final network. I'll start by looking at the auto-rigging setup. I'll get a second auto-rig component, and I'll be adding this after the auto-rigging component for the FK. To extend this, I'll need an edit graph node. The edit graph node will connect to the second input. I'll then update my auto-rigging node, and I'll set this to use the second input. Sometimes this will give me an error straight away, and I will often get errors on this node while trying to do this. The error that I get here will say that there is no character connected. Once this error is shown, no changes that I make to the network will make the logo disappear, and I'll constantly get a warning even if the network is working. But for the moment, this appears to be working correctly. So essentially what we're going to do now is we're going to use this graph to create a script. This script will be used to update our existing network, and we're going to use this script to add our extra functionality. We'll not cover the functionality yet. For the moment, I'll purely focus on actually adding nodes to the network. We can now start working on this edit graph node. We'll need the start and end for this network. The start will be a sub-network input, and I'll simplify the name to be palms. I'll also need a sub-network output. This will be renamed to output. After this, we'll need to get the information for our character. With the auto-rigger, I have not actually added a character to the graph explicitly. The character is actually being added with the first auto-rigger node, so we're not adding a .rig element in the packed folder node. This is actually being added in our first auto-rigger node. The auto-rigger is creating a character called base.rig, and this is done under the rig option. If we look at the geometry spreadsheet for this node, we can look under the detail attributes, and we should see that we've generated a rig path for this character. That is a reference for the character's rig, and this is based off the name of the rig which we're creating here. This is not how we access the character, but it does define the character that we are looking for. So our character is coming out of the FK node, and we're passing it into our new auto-rigger node, and this node is being set off the second input, and because of this we can now extract information from the character. To do this, I'll use an extract character graph node, and we'll use this to extract the build.rig graph. Although we can extract any graph and modify any graph with this. So we could use this to update our controls or our skeleton as well. The extract character graph node is not particularly complicated. If we enter the node, we can look at the functionality. This actually appears more complicated than it actually is. The majority of the nodes here are organizing information. The first major node is over here, which gives us a handle to the graph, and this is giving us our graph reference. We'll then test if we do have a graph, and if we do not have a specific graph mentioned, we'll load the graph from the geometry. So if we do not have an explicit graph to specify, we'll look for a graph on the geometry using a graph name. So we'll use this to get our character graph, and to get the character graph we need to specify the name of the graph. We can do this manually, but we'll use a different method with the auto-rigger. I'll connect the first input to my parameters, and this is the graph name input, and we'll use this to get the name of our graph. I'll then update the name of the input on my parameters node. This input will now be called rig name. So now we've created our character graph. We can then perform our operations, and after the operations are performed, we'll need to update the graph. And this will be done using an update character graph node. So essentially we'll extract the information, and then we'll update the information. We'll need the link to our geometry itself, and this will be done using the character input. This will be connected to our palms node. I can then connect my character geometry to the update character graph node. I'll connect the graph as well because that's what we're updating. We'll also want to connect the graph name output. This will give us our final geometry, and we can pass this into our output. So this will give us our basic setup. This will not necessarily update our auto-rigger node, as you'll see an error here. This is the error which I discussed previously. If I update the node, I'll still get an error, as well as a warning. I'll actually ignore this warning. This warning will usually go away if I restart Houdini. If I look at the unpacked results of this node, we should see that my network is still being generated, so this error is not actually affecting my functionality. This change to the network should not actually cause an error, as it's not actually doing anything, but as I said earlier, Apex is still beta software, so this kind of issue is expected. This is the error that I was speaking of previously. So before we continue, I'm going to discuss where we're getting the rig name value from. When I renamed the port, I renamed it to rig name. We cannot just use a name like this, it has to come from somewhere, and we can take a look at where this is being generated within the AutoRigger node. So I'll enter the AutoRigger node. So within this node, the rig attribute name is being generated within a node called getRigName. This is part of the section where we get the information about the character geometry, and this section is colored purple. This starts with an error checking section where we make sure we've got a character. We will then evaluate the character, and we'll create a couple of attributes here. The character will then be connected up to an invoke node, and this invoke node is labeled find or create, and this will run a graph which will process this information. Essentially, this will run a single node which is called find or create a packed graph, which is very similar in functionality to the extract character graph node, essentially the nodes which we have just used in our own graph. The major difference here is that this will create a graph if it does not exist, where the nodes that we are using allow us to work on an existing graph. The other main difference is we're using an existing rig name attribute, where within the AutoRigger node, it is adding that attribute to the graph here. So that's where we're getting this value from. We can now work on our network, and we'll do one basic function, which is we'll add a node to our network. So we're now going to update the graph. I'm going to pass the graph out to the output as well. I'll then get an add node. We'll connect the graph that we've isolated into this, and we'll pass the graph coming out of this back into the network. In our parameters, we can give this node a name. This is actually not the name of the node itself, but the name that the node will have in the network, so it can almost be thought of more as the label for the node. I'll call this test node. We then have the callback. The callback is actually the node type, so when we look at the drop-down menus over here, all of the node options will have a name, and this name format is actually what is used for the callback. So for example, I could use a cache node, and this is a SOP cache node. We can go to the geometry spreadsheet and we'll look at the point attributes. All of the points have a callback attribute, and the newest of these should have a callback which is SOP : cache. Once again, that's what we're using in the tab submenu path to find the node itself. So I can copy this value. In our graph, I can now specify that this will be the callback. I should now be able to examine the results in my final graph. In our final network, we should now have a node called test node. This node is a SOP.cache node. So we're now getting an existing network, and we're updating the network using an edit graph node. And this is how we'll add additional functionality for auto-rigging systems. We're now going to create this manually. I will not recreate everything from scratch. In this case, I'll duplicate the edit graph node that we have just created, and we can take a look at how this will be done using a basic edit graph network. So here we've added our base rig using an edit graph node, and we've generated this network manually. The other connections are for our geometry and for our skeleton. So this is giving us our network, and we want to be able to work on this network. To do this, I'm going to use an Apex invoke graph node. Previously, we've used this to add dictionaries to our network, but we'll actually be running our network on this node. The character will be connected to the second input. You should note that the character is not connected to the first input. The first network is actually the network we're running. So we're running the graph within this network, and that is using information from the second input. So the node that we're connecting to the first input is editing the network. It is not the network which we are editing. To look at our results, I can get an unpack folder node, and we can unpack the results of this network, and we're getting an empty network. So we're currently getting no result from this network. If we were to look at our rig tree, we'd see that we have an empty rig tree, and this will be the result for the invoke graph node as well. And this is happening even though we have a rig tree being passed into this node. So to get this to work, we need to update our parameters. First, I'll need an input binding. If we look at our input binding for the dictionaries, we should see that we have no entries here. so we do not have any parameters linked to the original geometry. The next option is to bind with geometry. We can activate this, and we should see that we actually have a character that can be bound to this geometry, and that character is coming out of our packed geometry node. Once again, this character does not have any dictionaries attached to it, so this dictionary will not import anything. So that gives us our input. Next, we can bind our output geometry. Because a character is now being passed into this node, we should have an option to pass the same character out of this node, and I'll set this to be output character. We can now test our network, and it should be generating correctly. If we look through the nodes of this network, we should see that we are producing a test node as the extra node for this network. So our edit graph network is working, and we are adding our node to this network. So essentially what we need to do within the invoke node is we need to pass our character into this node. The invoke node will then call our edit graph node, which is connected to the first input, and we'll get the output geometry from that node, which in this case is also called character. So in the edit graph, you can see that we're passing the input into the character here, and we're passing the output to the character over here. Now there is a mistake which we are making here, and we can assume that this is working, but it actually isn't. And that is because this is getting its network from the rig name parameter, but there is actually no rig name parameter. We should technically be specifying the rig name within this extract character node, or we should define this as a dictionary which is passed in through one of the inputs. So in the unpack node, I can specify that this will look at base.reg. And if we look at our network, we'll see that there is no extra node here. So I'll return to my edit graph node. I'll then select the extract character graph node, and I'm going to update the parameters. I'll set the rig name to be base.reg. When I now go to the final graph, we now have our test node, which has been added to this graph correctly. So we should note that the rig name parameter will be read from our auto-rigger node, where it will not be read directly from an invoke graph node unless we specifically add a dictionary containing that attribute within the second input of the invoke graph node. So for example, I could reconnect this. I'll call the parameter rig name again. I'll then get an attribute adjust dictionary node, and I'm going to create a dictionary here. If I wanted to, I could rename this dictionary. For example, I could call it dict, but I'll leave it at palms for now. We'll need to make sure that this is a detail attribute. The type will be a string. The key will be rig name. And the value will be base.reg. I can return to my invoke node, and I'll add a second input operation. The first input will no longer refer to my palms dictionary. However, the second input will refer to the palms dictionary. We can, of course, then link these parameters to the output, although this won't actually affect the functionality, but it does mean we can pass this dictionary on. Now using the rig name parameter should work, as we are reading the rig name dictionary off the input. So this is how the dictionary input will work, and our test node should still be added to the final graph. So that is how we can update our network. We'll continue to add functionality to the network next.